Use the given 0 to find the remaining zeros of the function. We have the polynomial function h of x equals x to the fourth minus 18x cubed plus 78x squared plus 294x minus 3,355. And we're given that this polynomial has a 0 of 6 minus 5i, and we want to find those remaining zeros. So one of the things that I notice here is that I have a complex 0, a 0 with I in it. And there's a theorem called the conjugate pairs theorem. I think this is supposed to be a J here, not a G. So the conjugate pairs theorem deals with polynomial functions with real coefficients. So you'll notice here that we have a real number 1 as a coefficient, the real number 18, the real number 78, the real number 294, the real number 3,355. So all of the coefficients on this polynomial function are real numbers. So we are going to be able to use the conjugate pairs theorem. And the conjugate pairs theorem says if we have this complex root, this complex 0, we are going to have the conjugate of this also being a 0 of the polynomial. So the conjugate of that is going to be 6 plus 5i. So we've already identified one of the remaining zeros using that theorem. So what I'm going to do is I know that when I have a 0 of 6 minus 5i, that there will be a factor of x minus 6 minus 5i. And since we have a 0 of 6 plus 5i, I will have a factor of x minus 6 plus 5i. I can multiply these two factors together and then use long division to reduce this polynomial down. So let's do that. Let's multiply x minus 6 minus 5i times x minus 6 plus 5i. If we multiply that together, I'll multiply these first two terms together. Those are the first. And I get x squared. And then I can multiply the outside two terms together. So this one is the outside and this one is the outside. If I multiply those together, I'll have minus x times 6 plus 5i. I can multiply the inside two terms together, so that's this one and this one. If I multiply those, I'll have minus x times 6 minus 5i. And I can multiply the last two terms together, that's these two. These two are the last. And that would give me a plus. Negative times negative is a plus. 6 minus 5i times 6 plus 5i. Alright, so I've got some simplifying to do. I'll use the distributive property here and here. And I need to multiply using that FOIL method again on that last part. So I have x squared minus 6x minus 5ix minus 6x plus 5ix. And we'll multiply these guys out. That is multiplying the first two together would give me 36. Multiplying the outside two together would give me 6 times 5i, and that is a 30i. Multiply the inside two together. That's a negative 5i times 6. That's a negative 30i. And then I'll multiply the last two together. And that's a negative 5i times a positive 5i. That's a negative 25i squared. So we have some more canceling and simplifying to do. For canceling, I have a negative 5ix and a positive 5ix. Those cancel. I have a positive 30i and a negative 30i. Those guys cancel. I know that I squared is the same thing as negative 1. So I'm going to be able to write this as x squared. I can combine these negative 6x's, that's a negative 12x. I've got a plus 36 and a plus 25. And that gives me x squared minus 12x plus 61. So what this does for me is it allows me to now reduce the polynomial by this factor of x squared minus 12x plus 61. And we're going to do that with long division. So I'm going to take this x squared minus 12x plus 61, and I'm going to divide it into x to the fourth minus 18x cubed plus 78x squared plus 294x minus 3,355. All right, so I start with this x squared. Try to match those leading terms. X squared times x squared will give me x to the fourth. I'm going to multiply that x squared times all three of these terms and write it down here. So x squared times x squared is x to the fourth. X squared times negative 12x, that is a minus 12x cubed. X squared times 61, that is 61x squared. Then I need to change the signs. So this is a minus plus minus. X to the fourth minus x to the fourth is 0. Negative 18x cubed plus 12x cubed, that's a 6x cubed, and it should be negative. And 78 minus 61, let's see, that would be 17x squared, and that's a positive. I'll also go ahead and bring down my next terms. 294x minus 3,355. Now we repeat that process over again. So now I need to do the same thing with a negative 6x cubed. And I would multiply this x squared by a minus 6x. So negative 6x multiplied by x squared, that's a negative 6x cubed. Negative 6x times 12, that's going to be a 72 plus 72x squared. And I don't know in my head what 61 times 6 is. 366, so that's going to be a negative 366x. I need to change the signs. This becomes plus minus plus. Negative x cubed plus 6x cubed cancel each other out. And then we have 17 minus 72. We get a negative 55 x squared. And we have 294 plus 366. That's 660x. And we'll bring down our next term. Okay, so now we need to repeat that process one more time, and we want to try to match it with the negative 55x squared. So times x squared would need to be a negative 55 to make that work. We have negative 55x squared and negative 55 times negative 12. We've got 660x, and that is a positive. And 55 times 61 will give me the 3,355, and that would be negative. We would change the signs, and all of these zero out now. We get a remainder of 0. So we were able to divide that out. So now we know, let me zoom out a little bit. Now we know that our fourth degree polynomial of x to the fourth minus 18x cubed plus 78x squared plus 294x minus 3,355 can factor into these two quadratics. This factors into x squared minus 12x plus 61 times x squared minus 6x minus 55. We already know the solutions to this one. That's where we got our zeros of 6 minus 5i and 6 plus 5i. And we need to now find the solutions to this quadratic. We can find the solution to every quadratic by the quadratic formula, but maybe we'll get lucky in this factors. So let's give it a try. So if I try to factor this, I get x and x. Factors of 55, I would try 5 and 11, with a negative on the 11 and a positive on the 5. And I can see that that will factor correctly. So I can get my remaining zeros by setting these factors equal to 0. That gives me a negative 5 and a positive 11. So we started off with this given 0. We used the conjugate pairs theorem to get this 0. And once we divided out that factor, we got the other two remaining zeros of 5 and 11. Thank you for checking out my videos. Have a great day.